All right, we made it to part 4 of our deep dive series. So, in this episode, we're diving into the world of carbon footprint metrics and their role in shaping investment portfolios. And by now, you already know how important integrating ESG factors into investment decisions has become. But today, we're going beyond the basics. We're going deeper. We're talking about carbon intensity, carbon adjusted returns, and the use of regression models when it comes to evaluating and optimizing portfolios with carbon constraints. Before we dive in, though, please hit that subscribe button so you never miss out on our latest episodes. Now let's jump right in. Okay, let's start with carbon intensity. This is basically a measurement of how much carbon dioxide a company emits for every dollar of revenue or assets. So it gives us a sense of how environmentally friendly a company is in terms of its operations and its business model. Now, this concept applies to whole portfolios as well. Just like companies, portfolios have a carbon intensity which reflects the average carbon intensity of the businesses it holds, weighted by their market values. The higher the percentage of a company's revenue that comes from fossil fuels, the higher its carbon intensity. To calculate the weighted average carbon intensity of a portfolio, we'll use this formula. WACS stands for weighted average carbon intensity. It's calculated by multiplying the carbon intensity of each individual asset in the portfolio by its weight in the portfolio. So that's the market value of the asset divided by the total portfolio value. Then we sum up all these products. Why do we do this? Well, because this WASI gives us a clear picture of the overall carbon emissions associated with our investment portfolio. And that's super valuable information for anyone looking to make informed decisions about their investments. Moving on, let's talk about carbon adjusted returns. This concept is pretty straightforward. It's about making adjustments to a portfolio's returns to reflect its carbon intensity. So, if a portfolio has a high carbon intensity, meaning it's made up of companies that emit a lot of greenhouse gases, then its returns will be reduced to account for this. The idea is that by considering carbon emissions, we can get a better sense of how sustainable a portfolio really is. Let's take a look at the formula for carbon adjusted return. So, the carbon adjusted return is equal to the portfolio return minus lambda multiplied by the WACI, the weighted average carbon intensity of the portfolio. Now, what does lambda represent? Well, lambda is a constant factor that you choose. It's essentially a way to control how much weight you want to give to the carbon intensity in your calculations. You can think of it as a way to balance the importance of financial returns with the environmental impact of your portfolio. Higher values of lambda mean that you're giving more weight to carbon considerations, which will result in lower adjusted returns for more carbon intensive portfolios. Next, let's explore some regression models that can help us understand the relationship between carbon related factors and the returns of our portfolios. One of the most widely used models is carbon beta. It's a measure of how sensitive a portfolio's returns are to changes in carbon intensity, and it's particularly useful for comparing different portfolios to see how they might react to shifts in investor preferences or changes in regulations related to carbon emissions. Think of it like this. If a company's stock price tends to move a lot when there are changes in the amount of carbon it emits, then it has a high carbon beta. On the other hand, if a company's stock price doesn't seem to care much about its carbon emissions, it has a low carbon beta. So, how do we calculate carbon beta? Well, it's all about looking at historical data. For example, let's say you have a portfolio with 5 stocks in it. First, you would gather data on the historical returns for those stocks, along with their corresponding carbon intensities. Then, using that data, you run a regression analysis, which is basically a statistical technique to find relationships between variables. In this case, you're trying to find the relationship between the carbon intensity of the stocks and their returns. Let's take a closer look at the formula for this regression model. The model assumes that the return on the portfolio, represented by RP, can be explained by a constant alpha plus the product of a sensitivity coefficient beta times the WACI, the weighted average carbon intensity of the portfolio. Plus, there's also this error term denoted by epsilon. So, beta in this context is the carbon beta. It tells us how much the portfolio's return changes for every 1% change in carbon intensity. And alpha is the intercept of the regression line, representing the return on the portfolio when the carbon intensity is zero. And finally, let's chat about how we can optimize portfolios with carbon constraints. This is all about finding the best mix of investments that gives us the highest returns while keeping our carbon footprint within a certain limit. It's a balancing act where we need to consider both financial goals and environmental impact. Let's say you're an investor who wants to build a portfolio with a specific target return, say 8%. At the same time, you also want to limit the carbon emissions of your portfolio. How do you do it? Well, you set a carbon constraint, which is basically a limit on the maximum carbon intensity your portfolio can have. So, in this case, you might say that your portfolio's carbon intensity can't be more than a certain threshold, say 50 tons of CO2 per $1 million of revenue. Now, how do you find the best mix of investments that meets these criteria? That's where optimization comes in. You use an optimization algorithm, which is a set of rules or steps that help you find the best solution to a problem. In this case, finding the best combination of investments that meet your return and carbon intensity targets. The algorithm will consider different combinations of investments and evaluate them based on how well they perform financially and in terms of carbon emissions. So let's take a look at the objective function of this optimization problem. It's simply maximizing the carbon adjusted return. Remember that carbon adjusted return we talked about earlier? Well, it's the thing being maximized in this case, and the variables are the weights of the assets in the portfolio. These weights determine the proportion of the portfolio that's invested in each asset. The objective is to find the optimal weights that give the highest carbon adjusted return while satisfying the carbon constraint. All right, we've covered quite a bit of theory, but now let's look at some visualizations to bring all these concepts together. I'll show you 3 important charts that can help us analyze and understand our portfolios better. The first visualization we'll look at is a scatter plot that shows the relationship between the carbon intensity of a company and its return. This scatter plot is actually for individual stocks. However, we can extend the analysis to portfolios by looking at the weighted average carbon intensity of the portfolio. Each point on the scatter plot represents a company or asset. The horizontal axis represents the carbon intensity of the asset, and the vertical axis represents the return on the asset. The idea is to visually see how these two variables are related. A positive relationship suggests that more carbon-intensive assets tend to have higher returns. A negative or zero relationship would indicate that carbon intensity might not be a significant factor in determining returns for these assets. Next, we'll look at a line chart that compares the carbon adjusted return of two portfolios. One portfolio will be without any carbon constraints, while the other will have a carbon constraint applied. Both portfolios will have the same target return. The x-axis of this chart represents time, and the y-axis represents the carbon-adjusted return. The line chart allows us to visualize how the carbon-adjusted returns evolve over time for both portfolios. The goal here is to see if and when the carbon-adjusted return with the carbon constraint starts to lag behind the one without the constraint. This chart can help us understand the trade-offs involved in incorporating carbon considerations into investment decisions. Finally, we'll examine a chart that shows the results of the portfolio optimization process with carbon constraints. This chart will include multiple points, each representing a potential investment. The x-axis will likely represent the carbon intensity of the investment, and the y-axis will show the return on the investment. The optimal portfolio will be the point that maximizes the carbon-adjusted return while satisfying the carbon constraint. This chart provides a visual representation of the trade-off between carbon intensity and returns, allowing us to see how the optimization process balances these two factors. Each of these visualizations brings a unique perspective to the analysis of portfolios, helping us better understand the complex interplay between financial returns and carbon emissions. And there you have it. From understanding carbon